the shortcut to safe AI. What if I told you that the most expensive, most time-consuming part of making AI image generators safe is now completely optional? For years, every major AI company has followed the same playbook. You train your model, then you spend months collecting thousands of carefully labeled examples of what's safe and what's not. Then you train a separate reward model to judge the outputs. Then you fine-tune. Then you test. Then you do it all over again. But what if you could skip all of that? What if you could make an AI model safer, without any safety data at all? That's exactly what a team of researchers just pulled off. And it changes the game for anyone trying to deploy AI image generators on a budget. Welcome back to the creative frontier. I'm your host, and today we're diving into day 15 of our research absorption, 298 papers deep, and the signal is getting clearer. Here's what you're going to learn. First, how researchers just eliminated the two most expensive components of AI safety training. Second, why text-to-music generation is converging on a clever dual-brain architecture. And third, why scientific image generation is stuck in a crisis that nobody's talking about. Stay until the end, because one of these papers reveals a fundamental truth about AI safety that might change how we think about alignment entirely. Let's start with the problem. You've seen the headlines. AI image generators can produce incredible art, but they can also produce content that's harmful, biased, or just plain inappropriate. The standard solution: safety alignment, and it's brutally expensive. Here's how it works. First, you need thousands, sometimes millions, of human-curated examples showing what safe and unsafe images look like. That's supervised fine-tuning. Then you need to train a separate reward model, basically an AI judge that can score how safe a new image is. Only then can you fine-tune your model to avoid unsafe generations. This is the pipeline that companies like OpenAI and Stability AI use. And it works, but it's also incredibly resource-intensive. You need teams of human annotators, weeks of training time, and massive compute budgets. The result: only well-funded organizations can do safety alignment properly. Smaller teams, researchers, or open-source projects are stuck using whatever alignment comes with their base model, or nothing at all. That's the problem, and it's a big one, because as AI image generation becomes more accessible, we need safety measures that are equally accessible. Here's where things get interesting. A new paper called Safe Diffusion R1 introduces what might be the simplest safety alignment method we've seen. The key insight: you don't need a dataset of safe images. You don't need a reward model. You just need the model's own understanding of what safety looks like. Here's how it works. The researchers use something called GRPO, Group Relative Policy Optimization. Think of it as training through trial and error, but smarter. Instead of having a human judge each output, they use a steering reward that's built directly into CLIP. That's the model that understands the relationship between images and text. Here's the clever part. CLIP embeddings already contain information about whether an image matches its caption. The researchers realized they could use this same property to steer away from unsafe content. If a generation is safe, say, a person in normal clothing, the CLIP embedding will have certain properties. If it's unsafe, say, a person in an inappropriate context, the embedding will be different. So instead of collecting thousands of examples of unsafe images and training a model to avoid them, they just said, "CLIP, you already know what's unsafe. Show us," and CLIP does. Through the steering reward mechanism, the model learns to avoid generating content that scores high on certain CLIP embedding properties associated with unsafe content. This is called